Okay, let's look at our third proof here in section 4 of our congruent triangle chapter. We are given that yx is equal to wx, and as you can see that's marked in our picture. Zx bisects angle x, or angle yxw. So this bisects this top angle. Kind of looks like a kite there. Okay, we're trying to prove that yz is equal to wz. So we're not trying to prove triangle congruency, but we need to get the triangles congruent. Okay, and probably we want to get triangle yxz congruent to triangle wxz, and then we can say that yz is equal to wz. So let me erase that. And let's start our proof. So obviously step 1 is the given. You would write these things right in there, and that's the given. Step 2, now, we know that yx is equal to xw, so we have a pair of sides corresponding that are equal. Zx bisects angle yxw. So if that's the case, I could then say that this angle right here is equal to this angle right here, because Zx is an angle bisector of that top angle there, that whole big top angle. So we're going to say angle yxz is equal to angle wxz, and that is what's an angle bisector, so that's the definition of angle bisector. Okay, so now I have a side and an angle. Can't quite say the triangles are congruent yet, but look at this. Look at this side they share, these two triangles. The triangles yxz and wxz. So we can say that a side is equal to itself, so I'm going to say xz is equal to xz. That's the reflexive property. So now, if you notice, I have that side equal to itself. I have an angle and a side. So I have the angle between two congruent pairs of congruent sides. So by side, angle, side, I can state that the triangles are congruent. So I would say triangle yxz is congruent to triangle wxz. And again, that's side, angle, side. So SAS congruency. And now once I get the triangles congruent, I can say any corresponding things are congruent, in this case sides. So I can say that yz is equal to wz, and that's by corresponding parts, congruent triangles, congruent.